Over the past few days, we've been investigating the issue of land reclamation and flood defenses in the Netherlands. As you probably know, if the lowlands of Holland were not dumped dry of water every day, they would soon be flooded by the ocean. However, in today's episode of our Floating Future series, we look at what may be an innovative way to survive global warming and rising sea levels. The Dutch are leading the way in development of communities that float on water.
This community of 4,000 residents is living on a polder below sea level. The reclaimed land is prone to flooding and must be constantly pumped to keep it dry. But very soon the houses, car parks, playground and supermarket will all be floating on water. The architect of the project is Cohen Olthuis of the company Dutch Water Valley.
It will be one big lake, a lake of 2.5 kilometers by a few hundred meters, and it's now still dry land, but afterwards we bring the water in. It will be 180 of water.
Dutch Water Valley apparently has a simple yet innovative solution to the problems of land shortage and rising sea levels.
The possibilities, the dreams, and making them come true now.
No, it's not technology, it's perception, because people have to believe that this is safe.
The concept goes beyond housing. In the future there could be floating beaches and islands, which would avoid the need to reclaim land and damage the fragile ocean ecology.
And this is very friendly for the environment, because if you make a normal island, you have to make a landfill, and then you will destroy all the water life. From here, still all the fishes will go underneath it, and the flow of water will go underneath it.
So how does a floating house work?
Floating houses, and they say as a normal house. You make a concrete box, you just build on top of a normal house.
Floating homes built by riverbanks can be kept in place with wooden pillars or anchor chains. On the sea, the structure is similar to an oil rig, with hydraulic columns reaching down to the seabed that move up and down with the rise and fall of the tide.
People will start to use floating houses, and slowly it will be a part of a normal city. You won't even see any difference between the border between land and water. You go just from normal land to floating land. Oh, you have floating land. Wow, I didn't even notice.
Do we really have a floating future? What's it like to live on the water? To find out, we went to meet Yvonne Priem, who had a boathouse for 30 years and has been enjoying life in a floating home for 18 months. Still by the river that she loves, Yvonne says the windows are bigger now and she no longer has a claustrophobic feeling. The biggest improvement is the home no longer rocks. Kept in place by fixed wooden columns, the whole home can move 20 centimeters up and down. Accustomed to living on the water, Yvonne says she puts her trust in the ability of the home to float.
This is where the boat is made of. This concrete.
For all intents and purposes, this is a normal home built in a floating concrete boat. The only difference is the bedroom is underwater.
The water is like this.
The two-story home with a basement has 5 rooms, each with its own view and independent air conditioning. Rain runs down from the roof through gutters into the river, while sewage, drinking water and power lines are connected to the land by plastic tubes.
It's nice living like this. Very nice living like this.
From an architectural point of view, floating homes are not difficult to build. So, is this the environmental resolution to the centuries-old battle against water in the Netherlands? What happens if the home strikes a leak? How will floating structures that block the sunlight affect aquatic life? These and other questions will have to be answered before the vision of floating cities becomes a reality. In today's episode of our series on a floating future, we move from Netherlands to Belgium, which is also a case study in how to deal with the threat of flooding. There we found Taiwanese student Zhou Bo-yi, who hopes to apply what he has learned back in his hometown of Pingdong. The southern Taiwan county suffers from land subsidence and saltwater intrusion, yet the solution to its problems may be as simple as just going back to nature.
Mention Belgium and most people think of the mannequin piece or rich chocolate, but ask an historian or an academic and you'll be told that this is the site of one of the oldest schools in the world, the Katholieke Universiteit Leuven, established in 1425. In the old market square, the Gothic town hall is a backdrop for the Fountain of Wisdom statue, which, like the mannequin piece, is often dressed in costume. The constant stream represents knowledge pouring into a student's head. It could also signify the vital connection between rainfall and underground water. In Europe, the cost of labor is high, but when it comes to maintaining tradition, no expense is spared. Cobbles are laid by hand, one brick at a time. And even if the surface is never as smooth as tarmac or concrete, the positive impact on the environment makes it worthwhile. This is a fact that Taiwanese overseas student Zhou Bo-yi is keenly aware of.
Taking Taiwan as an example, now a lot of coastal areas should not be drawing any more groundwater. There should be a strict ban on extracting groundwater.
Leaving Taiwan because he loves Taiwan, Zhou hopes that the lowlands can reveal a link between underground water and flood prevention.
Farmers always use pesticides or fertilizers, but what effect do they have on our groundwater? In this underground passage, you can see a lot of pipes and sensors to collect water, which is taken back to do chemical tests.
There are 3 different areas, and 2 of them we have to collect. The water is going into the bottles. So what it actually is, you have this distance, it's actually your water head. So you have here a section of, let's say, 1 meter.
These samples of underground water are what the team is studying.
So you see the drop that is forming.
The microsensors measure the flow of water and collect valuable scientific data.
In the experiments we use this. It's called a reflectometer. We can put it in the soil water level. It uses the principle of radar to calibrate the water content of the soil. I take the upper unsaturated level and isolate that section, then take the table water level in the saturated zone and isolate that, and then the river to make a combination of 3 areas. In this experiment, using samples collected on site, we can simulate the flow of pollutants.
Zhou developed a J-shaped tube which has sensors in different sections to measure the water flow and how nutrients and pollutants are transported between the soil and the river. The laboratory data is then compared to the situation on the ground.
This earth is all loam and clay. Of course, the flow of water through it is slower, unlike sand. Perhaps in one day, it will transport less than 1 centimeter.
Most rivers are formed by rain that seeps down to the water table before flowing out. Under the riverbed, stream water mixes with shallow groundwater in an area of porous soil called the hyporheic zone.
The so-called hyporheic zone is where stream water, groundwater and surface water come together. From an ecological point of view, its biodiversity is higher.
Compared to Zhou's home of Taiwan, where efficient drainage is a priority, natural meandering streams like this one are a rare sight. The scientist says it's an environmental disaster.
Speaking of Taiwan, a lot of streams, ditches and channels have been artificially reinforced with concrete. That means the water table and surface water don't have the opportunity to mix, so the ecology there has completely died.
soil and water experts like Joe are equivalent to the Earth's physicians in the way they diagnose floods, droughts, and other natural ailments. Who knows, the arrogance that leads us to meddle with the flow of our rivers and streams may also cut off our very life supply.